Hello everyone, today we're going to be going over the entire short answer section from the August 2022 Algebra 1 Regents exam. Yesterday we went over the entire multiple choice section, so today we're just going to finish off the whole test and do the short answers. A link to this test is in the description of this video if you want to follow along at home. And just a quick note that I will be using a graphing calculator, so I advise you use one too if you're following along. So we're going to start at question number 25. It says graph f of x equals the absolute value of x plus 1 on the set of axes below. That's the same thing saying y equals x plus 1 and graphing it. So in order to get full points, I'm going to have to graph this correctly, right? One graph. And I'm also going to have to include points. So the best way I think of doing this problem is to plug it into my calculator, my graphing calculator, and then go into my table, copy some points. So here's my x, here's my y. I'm gonna look at my table. I get -2, 1. I get -1, 0. I get 0, 1, and then I get 1, 2, and then I got 2, 3. Right, so all I did was I just plugged this into my calculator. I looked at my table. Next, I'm just going to graph these points as I saw it on my table. So here's -1, here's -2. So at -2, my y was 1, so I'm going to plot that right there. At -1, my y was 0, so I'm going to plot that right there. At 0, my y was 1, I'm going to plot that right there. And then at 1, my y, at 1, my y was 2, so I'm going to plot that right there. And then at 2, my y was 3, right? So right here, we have all of our points on the graph. Next thing, all you have to do is just draw a straight line between your points. So I don't have a graphing, I don't have a straight edge ruler, but you will on the test. So just connect it up with your ruler, make sure the line is straight, and always make sure to add these arrows at the end of your graph. Since they don't give us like a range or a domain, if they don't give you a range or a domain, you always have to put these arrows at the end of your graph. That just means that it keeps on going like that. Right, so we graphed it properly. This is how it looks like in my graphing calculator, and I also included my points, so I would get full credit for this. Number 26 says the table below shows the value of a particular car over time. Determine whether a linear or exponential function is more appropriate. So just remember that for a linear function, you have a constant y value. A constant y value. No, sorry, you have a constant rate of change. So sorry. Rate of change. Right, so it's, or same slope. And then just for an exponential function, it's exponential is the opposite. You do not have a constant rate of change. No constant rate of change. Rate of change. Right, so if we look here, let's find our rate of change. So we go from 20k to somewhere around 10k. So I'm gonna do 20,000 minus 10,550. So right here, the value of the car went down $9,540 over the span of 5 years, right? Next, it went down in value from $10,550 to being worth around $5,570. So if I do 10k minus like 5k, I get 4,980 over 5. Right, so that's a rate of change for 0 to 5 years. Here's a rate of change from 5 to 10 years. Obviously, these two are not the same number, right? They're not equal to each other, so our rate of change is not constant. So since our rate of change is not constant, and we just said that exponential function means that no constant rate of change, and exponential function is more appropriate for modeling this data because, and here's where we explain it, there is no, sorry, because the rate of change is not constant. Right, so it's an exponential function, is more appropriate for modeling this data because the rate of change is now constant. I would have gotten full points, right? Number 27 asks, is the product of radical 8 and radical 98 irrational? Rational or rational, justify my answer. So I could plug this into my calculator. I'll actually do it right now. I can do radical 8 times radical 98. Guess what? This times this is equal to 28. So my answer is rational, right? But they want me to justify my answer, and I could do this very easily. So in order to justify my answer, I'm going to do radical 8 times radical 98, right? I'm going to remember the rules when it comes to multiplying radicals. If I multiply a radical, right, I could combine these two over one radical sign, and I just multiply whatever's inside of them, right? So if I multiply these two, that's the same thing as saying radical 8 times 98, right? And this 8 times 98 is equal to radical, so 184. And this is equal to 28. And this is rational. Right, so there's my justification. And I'd say that it's rational. That's it. Right, so 28. The ages of last 16 United States president on their first inauguration day are shown in the table below. Determine the interquartile range for this set of data. So interquartile range, that can be used. You can use your calculator for the entire problem. So I'm going to go into stats. Right, I'm going to press stat. Then I'm going to go into edit. And I'm going to press enter, right? And next, I'm just going to input all of this data into one list, right? So I'm going to input my data, right? And then I'm going to go and I'm going to press stat again once I input my data. I'm going to go over into calc. So I'm going to press my arrow once into calc. And I'm just going to go and press enter. And then calculate. This is going to give you a bunch of weird symbols and weird numbers. The only thing that you really need to know, the only thing you really need to write down for this problem is are these datas. You know that your min value, you can scroll down by the way on this list. So you know that your min value x is equal to 43. My calculator gave me that, right? You know that Q1 is equal to 51. You know that the median is equal to 54.5, and you know that Q3 is equal to 61.5, and your max is 70. So interquartile range, or interquartile range is equal to Q3 minus Q1. That's just the formula. So I'm going to do 61.5 minus 51, and I'm going to get my interquartile range as 10.5. Right? And pretty much the only set of work you need to show here is this, right? All of this. You're going to have to copy down what you got from your calculator, right? And you're going to just have to show the formula and show you subtracting the two values. That's all. Just know how to use your calculator for that problem. Moving on to number 29, it says that the cost of 1 pound of grapes is G. The cost of 1 pound of grapes G is 15 cents more than 1 pound of apples A. The cost of 1 pound bananas B is twice as much as 1 pound of grapes. Write an equation that represents the cost of 1 pound of bananas in terms of the cost of 1 pound of apples, right? So I'm just going to go ahead, I'm going to write down everything that they just told me. So I know that grapes is equal to G, and I know that grapes, or G, is equal to 15 cents more than 1 pound of apples. So I'm going to write apples is equal to A. And they just told me that my grapes is 15 cents more, right? Whenever you say more, that's the same thing as saying adding it. So I know that it's A, or apples, plus 15, right? Next, the cost of 1 pound of bananas, so I'm going to have bananas equals B, right, is twice as much as 1 pound of grapes. So if you see twice as much, you know that you're multiplying by 2. Right? So if it's twice as much as 1 pound of grapes, we know that B is equal to 2 times G, right? And it's asking, write an equation that represents the total cost of 1 pound of banana and the cost of 1 pound of apples, right? So I know what G is, and I want to put everything in terms of A, right? And I already have an equation that gives us this in terms of A. So all I'm going to have to do is just plug in what I just said G is equal to, right? So here I have my bananas, and that's going to equal to 2 times G. And right here, I just said G is equal to A plus 15 cents, or like 0.15, right? Or I'm going to keep it as 1.5. So that's literally all you have to do. So that's the formula for the bananas. That's it. So all I did here was I wrote down the formula for grapes, I wrote down the formula for bananas, and the important part that they wanted to see here is if you would, all you have to do is just plug in your formula for G where it says G, and that's all. Right, so number 30 says the student is given the function f of x plus 1 squared and g of x is equal to x plus 3 squared. Describe the transformation of f of x onto g of x, right? So once again, I think the easiest way to solve this problem is to actually put it in your graphing calculator, and I'm going to do that right now. Right, so I'm going to scroll down to my graphing calculator. I'm going to input open parentheses x plus 1, and I'm going to square it, and next thing, open parentheses x plus 3 close parentheses squared. So I'm going to write down what I see, and it's graphing it. Okay, so for now, right, I have 1, 2, 3. Yep. And I know that one of my functions is going down like this. I know another one of my functions is going down like this, right? And it's touching this point. I'll go ahead and I'll draw that in a different color to make it look easier, or to make it look easier, to make it look better, right? So another one is touching it down at -3, right? The one that's touching it down on -3 is actually g of x, and the one that's touching it at -1 is actually f of x, right? So it's saying that describe the transformation that maps f of x onto g of x. So it's asking, like, how can we make this function into this function? Well, they're the same function, right? They look exactly the same. It's just that this one is 2 more units to the right than this one. So if I want to move this, all they're asking is how can I move this into this? And the answer is I can move it 1, I can move it 2. So in order to get this onto here, all I have to do is just take this and then move it 2 units and then graph it again, right? And it'll be the same function. So all I have to do to describe this transformation, all I have to write is you need to horizontally transform / move or move f of x 2 units to the left. That's all. Because if we look at how we did it right here, right? They were 2 units apart, and I wanted to move this one into this one. So all I had to do was just move it 2 units to the left. Or I needed to horizontally transform it 2 units to the left. And I forgot to put my t. Alright, 31 says solve 3x squared minus 5x minus 7 is equal to 0 algebraically for all values of x rounding to the nearest tenth. If I'm solving for the value of x and I have a quadratic, just remember the quadratic formula, right? So that's negative b plus minus radical b squared minus 4ac over 2a, right? That's all you can do to solve this problem, or the fastest way to solve this problem really is just to plug it into this formula, right? So our a value is going to be 3, our b value is going to be negative 5, and our c value is going to be negative 7, right? So here we're going to have 5 plus minus radical negative 5 squared minus 4 times a, so just 3, and then times c, which is negative 7, divided by 2 times 3, right? So I'm going to go ahead, I'm going to put that in my calculator, and it's going to give us, obviously it's going to give us two answers because we have a plus minus. So I'm going to put in my first I'm going to put in 5 plus radical negative 5 squared minus 4 times 3 times negative 7 over 2 times 3, and this is going to give me 2.573. And next I'm going to do the same thing. I'm going to plug the same thing into my calculator, but I'm just going to subtract it. And this is going to give me negative 0.906 for 31. And next, and all it's asking me to do is round it to the nearest tenth. So for me to round it to the nearest tenth, this is going to turn into 2.6. This is going to turn into negative 0.9. That's all you have to do. So x is equal to 2.6. X is equal to negative 0.9. And I'm pretty sure that's all the work you need to show. You just need to show the formula. Maybe you should combine like terms, so evaluate everything inside of the radical and then plug it into your calculator, but ultimately that's how you do it, right? So 32 asks us to factor completely this equation. So if I think about it, obviously I'm not going to FOIL it into two things because that's insane. 288, I don't even know one factor of that other than 144. So the next thing I'm going to look at is greatest common factors. I see that this is 3, I see that this is 12, I see that this is 288. So immediately I want to see if any of these, if all of them are divisible by 3. I know that 3 is divisible by 3, so yeah. I know that 12 is divisible by 3, it gives you 4. And I want to see if 288 is divisible by 3. It is, right? So in order to factor this out, I'm just going to write, I'm going to factor out 3, right? So now I'm going to have y squared minus 4y and minus 96, right? Because I know that's what that's equal to. So now I have I can deal with it much more easily. Now I can FOIL this out, right? Because 96 is a much smaller number. So I'm looking for something that multiplies into negative 96, but later adds to negative 4. I'm going to go ahead and save you some time. It's actually negative 12 and 8. Negative 12 plus 8 is negative 4, and negative 12 times 8 is negative 96. So I'm going to go ahead, I'm going to rewrite this with that in mind. I'm going to rewrite this as y squared minus 12y plus 8y minus 96, right? I'm going to factor out y, I'm going to get y minus 12, right? I'm going to factor out 8, I'm going to get y minus 12. I'm going to combine them, so y plus 8, y minus 12, and 3. That's that equation completely factored out, right? So moving on to part 3, scary. Thomas took a 140-mile bus trip to visit his grandparents. His trip is outlined in the graph below. So we have miles and we have hours. So this is pretty much giving us speed in miles per hour. The slope is the speed. So explain what might have happened in the interval DE. So like I just said before, this is giving him miles over hours. So miles over hours, in other words, is just speed. So here we see that the slope isn't changing, right? That means that over here, he's not traveling any miles. He's staying at 110 miles for about like half an hour, right? So if your distance traveled stays the same, what does that say about you? That means you're not moving, right? So what might have happened between interval DE, where his distance traveled does not change? Miles may have stopped moving. Right? So next we're going to say that it asks us to state the interval in which the bus traveled the fastest, right? So the interval where he traveled the fastest. Well, let's see here. So obviously the steepest, so when he traveled the fastest pretty much is asking us which one of these intervals has the steepest slope, or the slope that's the steepest, because that's how you figure that one out. So if you look over here at this graph, honestly, you could just save yourself some time and eyeball it. E to F is going to be way flatter than C to D, right? And if we look at C to D and A to B, the way I see it, I think C to D is steeper, right? Obviously, you can calculate the slope, right? So you could do like 1 minus 2.5 over 20 minus 110. But from the way it looks, C and D seems to be the steepest. So I'm going to go ahead that he traveled the fastest. During hour 1 to hour 2.5. Or he traveled the fastest during between the time of point C and point D. Or I could just write the interval as 1 and then as 2.5, right? And then I could call it a day, right? And I could say state how many miles per hour the bus was traveling during this interval. Well, this is relating back to this problem, right? So it's saying, well, now I'm going to have to actually calculate the slope, right? So how many miles per hour? That's miles over hour. I've said this 1,000 times. That's just speed. So I'm going to go ahead. I'm going to go calculate that. I'm going to do 2.5 minus 1 over 110 minus 20, right? So if I go calculate that, 110 minus 20 over 2.5 minus 1, that's going to give you 60, right? So the bus was traveling at 60 miles. Oops, sorry. 60 miles per hour, right? And, you know, just like I was saying, you could have done this thing where you just calculated the slope for interval AB, for interval FE. That's how you could have calculated, and whichever value would have been the highest is how you would have calculated when he was traveling the fastest, right? Also, I noticed this is about a bus, so maybe a better explanation for this one would have been the bus stop moving instead of miles, but ultimately it doesn't really matter. So the final part for this is asked, what's the average rate of speed in miles per hour for Thomas's entire bus trip? So instead of looking at an interval, like for example C to D, right? Also, for this interval, you could have also stated from point C to point D, same thing. So we're looking at from A to F. So instead of just limiting ourselves to this X value, to this X value, right? We're going to look at the entire thing as a whole. So we're going to look from 0, 0, right? All the way to 4, 140. So I'm going to go ahead and write that. Remember the formula for rate, formula for slope is x2 minus x1 over y2 minus y1. Right, so here we have x2, which is 4 miles per hour. We're subtracting that from our x1, which is 0. Next, what we're doing is we're subtracting y2, which is 140, minus our y2, which is, minus our y1, which is 0. So now we have 140 over 4, right? If we calculate that, we get 35 miles per hour. And just remember to add your units. And that's it. That's how you would do number 33. Moving on to number 34, it asks us to graph f of x and g of x on the set of axes below. And it gives us this x squared minus 4x plus 3, and it gives us g of x is equal to 1/2 x plus 1. So I see no issue, I see no confusion. Just plug this into your graphing calculator. Right? I'm plugging it in right now. It's already in terms of y for you, which is super nice of them to do. And it's graphing it for me. Boom. All right, it graphed it for me. I'm going to go ahead, I'm going to do my little trick where I go into my table, right? So I'm going to make a table for f of x, and then I'm going to make a table for g of x. And right here, I'm going to make a table for f of x. Right? So here's x, here's y, here's x, here's y. Okay, cool. So if I look for my table for f of x, which is the thing that I graphed first, at 0, it's going to be 3. At 1, it's going to be 0. At 2, it's going to be -1. At 3, it's going to be 0, right? Okay, and now if I look at my second graph, I'm going to start it from 0 also. So at 0, my graph is 1. Then at 1, it's 3 over 2. Then at 2, it's 2. Then at 3, it's 5 over 2. And so on and so forth, right? So I'm going to go ahead, I'm going to plot these 2 points, plot all these points, and I'm going to connect them. So at x equals 0, my y is 3, so right there. At x equals 1, my y is 0. At x equals 2, my y is -1. X equals 3, my y is 0. And I'll throw in a bonus point. When x is 4, my y is 3, right? So next I'm going to plug in I'm going to go ahead, I'm going to connect these points. This looks like this is an exponential function, so make sure to curve it at the bottom, and then make sure to draw your lines facing outwards. Obviously, try to connect it as smoothly as possible, like that, but I'm sure this will do. And also make sure to label it as f of x. So next I'm going to go ahead, I'm going to draw my g of x. So when x is 0, my y is 1. When y is 1, since it's a fraction, I'm just going to go ahead and skip to when x is 2, this is 2, right? And all I'm going to do is I'm just going to draw my line just like that. Unfortunately, it crossed where I labeled the other function, so this is now g of x, right? And we add our 2 arrows, and this is once again f of x. So those are my 2 functions. I have clearly labeled points. My line pretty much runs through my points, There, now it crosses the points. That'll give me full credit on that. And then part 2 says, based on your graph, state one value of x that satisfies f of x equals g of x. So all that means is, where do they intersect, right? So let's see where they intersect, man. Well, if I look back at my graph, I know that they pretty much intersect somewhere around this point, right? But the way that my graph is, I don't know what my x value on that one is. So I'm going to go back to my graphing calculator. Here's the graphing calculator formula, right? So I'm going to go to my graphing calculator. I'm going to go into, I'm going to press my graph button, right? Next, what I'm going to do, I'm going to go into second. right? And then I'm going to press plus trace. So I'm going to go into second trace, right? And then I'm going to scroll down to where it says intersect. And I'm going to select one of my graphs. I'm going to select another one of my graphs. I'm going to press guess, right? And what I'm going to get is 0.5. I'm going to get either 0.5 or I'm going to get 4, right? And that's all you need to do. Like next, all you need to do is just write those values down here. So, and it's saying one value, so I'm just going to go for 0.5. So I'm going to say x equals 0.5 because, and my reasoning is because the two graphs intersect at that point. That's all I need for full credit. X equals 0.5 because the two graphs intersect at that point, right? And we just said that, oh, what is this point? This point actually was 0.5, and that's all. Also, if you had a straight edge ruler, if you had graphed this neatly, you could have also seen that at 1, 2, 3, 4, they also intersected at this point. You could have just wrote down 4 instead of using your calculator, but I would advise you to use your calculator, go into trace and intersect and actually calculate it. Right, so 35, second to last question, I think. Never mind. 35 says a store sells grapes for $1.99 per pound, strawberries for $2.50 per pound, and pineapple for $2.99 each. Jonathan has $25 to buy fruit. Right? He plans to buy 2 more pounds of strawberries than grapes, and he also plans to buy 2 pineapples. If x represents the number of pounds per grape, write an inequality that models this scenario. So we know if that x equals grapes. I might as well define every other variable, so I'm going to say that s is equal to strawberries too. Right? So I'm going to go ahead, I'm just going to write down everything that was given to me, right? So it sells grapes for $1.99 per pound. Whenever I see per pound, that's the same thing as saying multiplying. So I'm going to do $1.99, right? Times x, which is grapes. So x is g, right? And we're selling strawberries for $2.50 per pound. So we know that we're going to have 2.5 or 250 times s. And we know that pineapple is just $2.99 each, right? So Jonathan plans to buy 2 pounds of strawberries, 2 more pounds of strawberries than grapes, right? So how do we model that? All we have to do is just put x plus 2. The number of grapes, which is x, and then plus 2 is equal to s, right? So strawberry is equal to x plus 2. And he also buys 2 pineapples, so we're just going to be left with 2 times $2.99. And that's all, right? So if x represents the number of grapes, right, in the inequality to model this, so I just wrote down everything that I know, right? That's everything that was given to me. That's all that I know, right? Now I'm just going to write down the inequality. So I'm going to write down 199 times x, right? And then I'm going to add that to 250 times s, but he wants only one variable, right? But guess what? We just said that s is equal to x plus 2, so we're going to do 250. Actually, just to make it more clear, we're going to do 1.99 times x plus, here's our strawberries, I'll write that in red, 2.50 or 250 times, and we already said what s was, it's x plus 2. Right? Plus, he also plans to buy 2 pineapples, and we have that down right here, 2 times 2.99, right? And all of this has to be less than or equal to 25. So less than or equal to 25, right? Because he only has $25 to buy this with, right? So his total cost can't go over that. And I'll go write this down in, and that's our total cost, so it can't go over that. And that's it. That's all you need to write down. That's the equation. All right, so moving on, number 2, or part 2. Determine algebraically the maximum number of whole pounds of grapes that he can buy. So pretty much the first part of this asked us, hey, solve this. The second part of this is asking us, the first part was asking us, hey, model this. And the second part of this is pretty much saying, hey, solve for x using your formula. So assuming that we wrote this down right, which we did, we're going to rewrite this. And we're just going to solve for x, right? So 1.99x, we're going to distribute this out. So now we have 2.5x plus 5 plus 2 times 2.99 is what? Let's see. 2 times 2.99, or 299, is 5.98. And all of that is greater than or equal to 25. I'm going to combine like terms. 1.99 plus 2.5 is equal to 4.49. 4.49x plus 10.98 is equal to 25. I'm going to subtract 10.98 from both sides. Right, so 25 minus 10.98. So I'm going to get 4.49x is equal to 14.02. I'm going to divide both sides by 4.49. Divide both sides by 4.49. I'm going to get that my x is equal to 3.1224, and then it goes on forever. Right, so it's saying determine algebraically the maximum number of whole pounds, right? And this whole pounds is pretty important, right? Because what that tells us is we're not going to have like half a pound, a quarter of a pound. It's just asking us for the whole number, whole pounds, right? So if we look here, we're going to have to round down, right? So you can buy 3 whole pounds. That's it. Right, asking us for the whole pounds. We're not going to write down 4 because 4 is way bigger than what we have. So he can buy 3 and he can buy a couple extra, but he's just asking us how many whole pounds. 3 is the answer. So moving on to number 36, it says solve the system of inequalities on the set of axes below. Label the solution set S. So dealing with some inequalities here. First thing that I would do is, for me personally, I would put these all in terms of y. Just that, so that we can plug that into our graphing calculator and make it a little easier. So over here, in order to get this in terms of y, I'm just going to subtract 3x on both sides. So I'm going to have y is greater than 5 minus 3x. Right here, I'm going to have, all I'm going to do is add y on both sides. Right, so here I have y is greater than or equal to, and I'm going to subtract 1 from both sides, 2x minus 1. So the next thing I'm going to do, I'm going to press y equals. I'm going to input both of these graphs. And I'm going to graph it, right? So once I graph these, I'm going to go into my table and I'm going to make a quick table. And I'll also go ahead and I'll rewrite this in red to make it a little easier. Cool. So, okay, I'll just have a red table and I'll have a blue table. So here's x, here's y. So for my first equation, which is going to be 5 minus 3x, and I look at my table, I'm going to have negative 2, and then I'm going to have 11. Next I'm going to have negative 1, I'm going to have 8, and I'm going to have 0, and then I'm going to have 5, right? Next I'm going to look at my red graph. I'm going to have 0, I'm going to have negative 1, I'm going to have 1, I'm going to have 1, I'm going to have 2, and I'm going to have 3, right? I think that's enough points for us over there. So next I'm going to plot this out, right? So here's when x is 0, y is negative 1. When x is 1, y is 1. When x is 2, y is 3, right? So also it's a straight line from here, so I'm going to go ahead and I'm going to connect these points. Remember, on the real test you have a straight edge. In this video I have my steady hands. And also, just a quick reminder, I'm going to draw a two arrows at the end. And remember, I'm going to make this a solid line because in our graph, we have a greater than or equals to. So greater than or equal to is a solid line. And if we just have if we have a less than, or if we have a greater than, that means a dashed line. Dashed line. Right? So next we're going to go ahead and we're going to correct. And also, since this is y is greater than or equal to, we're going to have to shade downwards or to the left, right? So I'm going to quickly go ahead, I'm going to shade this in like so. Okay, and why is that? Well, since y has to be greater than or equal to it, the solution isn't going to lie here, right? Because, for example, here we have 1, 2, 3, but this is actually 1. Oh yeah, so the solution can't lie outside of the shaded area, because if x were to be 3, right? 1, 2, 3. If x were to be 3, that'd be 6 minus 1, which is 5, and 5 is not less than or equal to our y value of 3, right? So just make sure. Pretty much all I'm saying is just shade inwards if it's less than or equal to, or if it's looking like that, right? Next thing we have to do is we have to graph our blue equation. Right, so here we're going to have -2, and we're going to go all the way up to 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So -2, 11, all the way up there. Next we're going to go -1. We're going to go 1, 2, 3, 4, 5, 6, 7, 8, 8. And we're going to have 0, and we're going to have 1, 2, 3, 4, 5, 5. We have a straight line. We're just going to... Wow, that was not a straight line. Straight line. We're going to just shade all the way down, right? Boom, boom. And remember, guys, I actually made a little mistake here. This like I said before, this needs to be a dashed line. So just make a quick dashed line going all the way down. It's a dashed line because it's greater than, which means that our solution set cannot lie on these points. Okay, and just a quick note, once again, we're gonna have to shade to the left because it's this sign, right? Or never mind, because our y is gonna be less than that. So we're gonna go ahead, we're gonna have to shade down. I don't think there's any way to make this not look sloppy, but here we shade it down, and what it's asking us to do is label the solution set S, right? So we graph both of these, and then we also shaded where we needed to shade based on our sign. Now all we have to do is label the solution set S, and the solution set S is where the two shaded areas intersect. So where do I see them intersect? I see them intersect here, so our solution is going to lie here. S is going to lie here, right? Next, part 2 asks, is -5, 0 in the solution set? Well, let's check. So 1, 2, 3, 4, 5. That's -5 and 0. Well, -5 and 0 is in the area that has both of the shades. So yes, -5, 0 is in the solution set because it satisfies both equations. Pretty much what that's saying is that if you plug in -5, 0 into the numbers here, it'll satisfy both of them, right? So moving on to the last question, number 37. Sorry for the long video. it tells us that an ice cream shop sells small and large sundaes. One day, 30 small sundaes and 50 large sundaes were sold for $420. Another day, 15 small sundaes and 35 large sundaes were sold for $270. Sales tax included with the price. Right, the first part of this asks us if X is the cost of a small sundae, Y is the cost of a large sundae. Write the system of equations to represent the scenario, right? So just like with every other problem that we solved here, we're gonna have to write down everything that they told us. So we're writing down the equations for both days. So one day we had 30 small sundaes, right? And 50 large sundaes. So if X is the cost of a small sundae, so we have 30X plus, then he sold 50 large sundaes, right? So here we have 50Y, and this is equal to $420. And here we have another day he sold 15 small sundaes, so 15X plus here he sold 35 large sundaes, and that's all you need to do to show the system of equations, right? So on one day he sold 30 small sundaes plus 50 large sundaes, so 30X plus 50Y, and he got $420 in total. That's the total. On another day he got 15 small sundaes and he got 35 large sundaes, and the total was $270, and that's shown right there, right? So that's all we need to do to represent the scenario in the system of equations. So second one says that Peyton thinks that the small sundaes cost $275 and large sundaes cost $675. Is Peyton correct? Justify your answer. Well, we just modeled the scenario, right? So the easiest way to check if Peyton's correct is just to plug in those values, right? So here we're gonna have 30 small sundaes times 275. And here we're gonna add 50 large sundaes times 675, and we're going to check if it equals to 420. Here we're going to write down 15 small sundaes. We're going to multiply by 275 plus large sundaes, which is 35 of them, and then here's 675. And both of these should add up to, this one should be equal to 420, and this one should be equal to 270, right? So let's see. Let's plug that into our calculator. 30 times 275 plus 50 times 6.75. This is equal to 420. So far so good. He's right. And let's look at the second one. 275 plus 35 times 6.75. Oh, it appears Peyton made a mistake. This is equal to $277.5, right? So he's wrong. So our answer is no, because, or actually, do we need to explain? Oh, justify our answer. Well, this is enough justification right here, right? All we have to write is no, 277.5 is not equal to $270, right? That's pretty much all that you need for that one, right? So moving on to the last part of this. Oop, I don't know why my mouse isn't responding. Okay, so moving on to the last part. You could have also written that like Peyton is wrong because if you plug in the values for the second equation, the two values don't match up, but whatever. Using your equations, determine algebraically the cost of one small sundae and the cost of one large sundae. So here we're going to have 30x. We're just going to rewrite our formula. 30x plus 50y is equal to $420. Here we have 15x plus 35y is equal to 270, right? So we're solving for x and y. So one way to solve a system of equations like this is just to make two values equal to each other and then subtract them. So in this case, we're going to look down. We're going to see that, well, 30 is just 15 times 2. So I could rewrite this as 30x plus 50y is equal to 420. Right? I could multiply this entire side by 2. So I could just do 30x plus 70y is equal to 270 times 2, 540. Right? And next, I could subtract these two sides from each other. I could get negative 20y is equal to 420 minus 540. So negative 20y is equal to negative $120. I could just divide both sides by negative 20, divide both sides by negative 20. I get y is equal to 6. So actually, Peyton, you were 75 cents off, but one large sundae is equal to $6. And all we have to do now is we could just plug in 6 for one of our equations. So I'm going to do the top one. So 30x plus 50 times our new price is equal to 420. So here we're going to have 30x is equal to 30x plus 300 is equal to 420, right? Because 50 times 6 is 300. And next we're going to subtract 300 from both sides. We get 30x is equal to 120. So x is equal to 4, right? So now we're going to do small sundae is $4 and a large is equal to $6. That's all you need to do for this. This was a system of equations problem. Just plug it back into your formula, cancel both terms out. That's the end of this review. So sorry that it went on for so long, but if you have any questions, feel free to let them put them down in the comments. Feel free to subscribe if you like this video, or just leave a like if you liked it. Thank you for watching. I'll see you later.